Look closely at your hand. It seems solid, right? But what if I told you that, beneath the surface, there's a hidden world more mysterious than anything you can see with your eyes? Zoom in, past the skin, past the cells, even past the molecules and atoms, and you'll find a world that defies common sense, the quantum realm, where the rules are unlike anything we experience in daily life. Here, particles can exist in many places at once, and can be mysteriously linked across vast distances, as if they share a secret connection no matter how far apart they are. These strange rules aren't just theoretical, they're the very foundation of our reality, shaping everything from the smallest particles to the largest galaxies. Quantum physics explains why the sun shines, how computers process information at lightning speed, and why matter itself holds together, forming the world as we know it. For decades, this realm was untamable, governed by uncertainty and probabilities rather than certainties. But now, scientists are learning to control it, unlocking new possibilities and sparking a technological revolution that could change everything. Understanding the quantum world is as transformative as harnessing electricity or splitting the atom, moments that forever changed human history. The technologies emerging from this field will dwarf today's supercomputers, opening doors to breakthroughs in medicine, communication, and energy. They'll help us solve problems we once thought impossible, from curing diseases to unraveling the mysteries of the universe. So, let's journey down to the unimaginably small, guided by curiosity and the drive to understand what makes our universe tick. We'll explore the latest discoveries, witness experiments that push the boundaries of knowledge, and meet the brilliant minds shaping our future, whose work is redefining what's possible. Their quest is paving the way for a world that's brighter, faster, and more connected than ever before. This isn't science fiction, it's the next chapter of human progress. This is the story of what's happening right now in our corner of the cosmos, a story that's only just beginning. Imagine trying to build a delicate card tower while the ground shakes beneath you. Every move you make could send the whole thing tumbling down. That's what it's like to create quantum computers. The process is a constant battle against instability, where even the tiniest vibration or stray signal can spell disaster. Qubits, the fundamental building blocks of quantum computers, are incredibly fragile. They can exist as 0, 1, or both at the same time, a phenomenon called superposition. But this remarkable property comes at a cost. The slightest disturbance, even from background noise or temperature changes, can ruin everything in an instant. This fragility is known as decoherence, and for years, it has been the biggest obstacle standing in the way of practical quantum computing. In 2024, however, researchers achieved a major breakthrough in quantum error correction. Think of it as an autocorrect for the very fabric of reality itself. Instead of constantly checking the qubits directly, which risks disturbing them, the new system monitors the relationships between qubits, gently nudging them back on track when they stray, all without destroying the precious quantum information they hold. Previously, protecting a single logical qubit required thousands of physical qubits, making large-scale quantum computers seem out of reach. Now, thanks to these advances, just a few dozen physical qubits can do the job, dramatically reducing the complexity and cost. This shift is a game-changer, making the dream of large, reliable quantum computers far more achievable than ever before. It's a foundational leap, as significant for quantum technology as the invention of the transistor was for classical computers. The dream of useful, everyday quantum machines is no longer a distant fantasy. It's becoming a reality. We're moving from fragile, proof-of-concept experiments to building true quantum processors that can tackle real-world problems. The once daunting fragility of the quantum world is now being tamed, transformed into a manageable engineering challenge. The era of practical, powerful quantum computing is finally within our grasp, promising to revolutionize technology as we know it. We're learning, step by step, to make the quantum world work for us, and the future has never looked more exciting. Einstein called it spooky action at a distance, quantum entanglement. For years, we could only entangle pairs of particles. In 2024, that changed. Scientists at the Max Planck Institute entangled thousands of atoms in a stable, unified quantum state, using grids of laser light. These atoms acted as one massive quantum object, linked in a complex symphony. The real breakthrough: they held this entanglement for several seconds, an eternity in quantum terms. This opens the door to ultra-precise sensors, secure communication, and new quantum technologies. Large-scale entanglement is key for quantum networks and advanced measurement tools. We're not just pushing boundaries, we're building new ways to see and shape our universe. The quantum orchestra has arrived. Some problems are too complex for even our fastest supercomputers, like simulating a protein's folding. Classical computers would take eons. Quantum simulators can do it in moments. In 2025, scientists built specialized quantum simulators that model real quantum systems, not just run algorithms. These devices act out quantum problems, exploring countless possibilities at once. Already they're helping design new materials and drugs, and probing the secrets of superconductivity. Quantum simulators let us build artificial universes to test ideas directly. We're not just observing the quantum world, we're engineering it. This is a new way of doing science, unlocking discoveries impossible before. The age of quantum simulation has begun. Every scientific breakthrough has a human story behind it, a tale of curiosity, persistence, and vision. Meet Dr. Eris Thorne, a physicist whose journey would quietly reshape the future of quantum computing. In a modest university lab surrounded by aging equipment and the hum of possibility, Thorne and his small, dedicated team obsessed over a single stubborn problem: decoherence, the nemesis of quantum computers. While other researchers raced to build machines with ever more qubits, Thorne took a different approach. He focused on stability, famously asking, "What good are 1,000,000 drunken soldiers? I'd rather have 3 sober ones." Drawing inspiration from biology's resilience, he dreamed of qubits that could heal themselves, just as living cells repair their own damage. After countless late nights and endless cups of coffee, a sharp-eyed student noticed something unusual, a repeating pattern in the noise, like an echo hidden within the chaos. Thorne realized that the system's own interference, once seen as a flaw, could actually be harnessed as a tool, not an enemy. Working together, the team designed special control pulses to exploit these echoes, dramatically extending the coherence times of their qubits. Their humble 3-qubit system soon set a new record for stability, astonishing even the most seasoned experts. At first, the scientific community was skeptical, questioning whether such a simple idea could really work. But soon labs around the world began to replicate Thorne's results, confirming the breakthrough. The Thorne Echo Cancellation method quickly became a cornerstone of modern quantum error correction, changing the field forever. Thorne's story is proof that big leaps in science often come from small, passionate teams with bold, unconventional ideas. Sometimes all it takes is a fresh perspective and the courage to follow it, to change everything. Stable qubits, massive entanglement, powerful simulators. What does it mean for us? The first impact: medicine and materials. Quantum simulators are already designing custom drugs and new catalysts to fight climate change. Next, information security. Quantum networks promise unhackable communication. If intercepted, the message self-destructs. This could revolutionize privacy, finance, and global security. Quantum sensors will transform measurement, from early cancer detection to monitoring climate change, with unprecedented precision. These tools will give us new senses to perceive our world. And then, the full-scale quantum computer optimizing global logistics, discovering new math, simulating the brain, or searching for alien signals. These aren't just faster computers, they're tools to solve humanity's toughest challenges. The quantum revolution is already underway. Its benefits will touch every part of our lives. The future is being built now, in labs around the world. Quantum tech is about to change everything. Despite our progress, the quantum world remains mysterious. The measurement problem: when does a particle's fuzzy state become real? Is a conscious observer required? Quantum mechanics and gravity, our two best theories, don't work together. Uniting them is physics's holy grail. Most of the universe is dark matter and dark energy, unknown, invisible, possibly quantum in origin. Could quantum physics explain these cosmic mysteries? New sensors and experiments may soon reveal answers. These questions aren't failures, they're the fuel of science. They inspire the next generation of explorers. With new quantum tools, we're probing deeper than ever before. The unknown is calling, and we're ready to answer. How do we explore the quantum realm? With extraordinary tools: optical lattices, grids of pure light, trap atoms in programmable patterns, letting us simulate new materials or even the early universe, dilution refrigerators, gleaming like golden chandeliers, cool quantum chips to near absolute zero, silencing atomic noise. These machines, along with single-photon detectors and atomic clocks, are marvels of human ingenuity. Each new instrument lets us ask deeper questions and get clearer answers. They're not just windows, they're active probes into reality's fabric. As our tools improve, so does our understanding of the cosmos. The history of science is the history of its instruments. Our quantum tools are opening a new chapter. We live in a special moment, no longer just wondering, but building with the quantum world. The breakthroughs of 2024 are a beginning, not an end. Curiosity drives us, just as it drove explorers across oceans. Today's scientists, tinkering with lasers and equations, are charting new territory within every atom. Their work shows what's possible when we embrace the strange and collaborate globally. The universe isn't obligated to make sense, yet through science, we find unity and beauty. Quantum physics connects us to the cosmos at the deepest level. We're not just in the universe is in us. Next time you use your phone or see sunlight, remember the quantum dance behind it all. The journey of discovery is far from over. More mysteries await, more wonders to uncover. The cosmos is waiting, and our most powerful tool is a curious mind. The adventure has just begun.